Good morning, everyone, and welcome to the environmental science session. As I told you that we are going to study in chapter 3, which is the first chapter in quarter 1, energy and chemistry of life. Last week we studied the basic definition of the energy and the different forms of energies, and we are trying to relate each type of energy to a real life application. And then the second part in this chapter is talking about chemistry of life. Let's go quickly through the types of energy to finish the last part in the energy types, and then start with the second part. We have the mechanical energy, and by the way, you may be asked to calculate it through its given mathematical equation. We have chemical energy. You may be asked where it's found or where we can find the chemical energy. Electrical energy, that it's related somehow to the flow of electrons. And radiant energy, it's the waves that's coming out of the sun. And what are the waves? We have visible light, we have ultraviolet radiations, we have infrared radiations, we have microwaves, radio waves, and so on. Thermal energy or heat energy, that's related to the vibration of molecules in a substance. And let's go to the last part, which is nuclear energy. What's nuclear energy? Nuclear energy, basically, it comes from the binding of protons and neutrons that made up the nucleus of the atom. We know that the atom is made up of three main particles: the proton and the neutrons and the electron. When we have energy that comes out of the protons and neutrons, this is called nuclear energy. Actually, we have two subtypes of nuclear energy, whether nuclear fusion or whether nuclear fission. What's this? Nuclear fusion, the energy is released when atoms are combined or fused together. While in nuclear fission, energy is released when atoms are split apart, which means if you split an atom, this is nuclear fusion. If you bind one atom with another atom, this is nuclear fusion. If you split, this is fission. If you bind, this is fusion. Okay? So fusion means binding and fission means splitting. Okay. You have to know that we have a law that's called the law of thermodynamics. What's thermodynamics mean? Thermodynamics is a study of energy. So studying thermodynamics is a studying of the energy. Okay, we have two laws of thermodynamics. The first law of thermodynamics called conservation of energy. Conservation of energy. It states that the energy may change from one form to another, but the total amount of energy will remain constant, which means that if a machine is having input energy by a certain amount, the output energy is going to be with the same amount. It's going to be constant, and only the form of energy is going to be changed. Okay, he's giving us example here. For example, in a motorcycle, the chemical potential in the fuel is going to change into kinetic. And also in the radio, the electricity is converted into kinetic and sound wave. Okay? The second law of thermodynamics is important to environmental science, and it states that this organization or entropy means this organization or random, this increases in natural system through any spontaneous process. Okay. The units, you have to be aware of the units. We have the joule for measuring the energy, and we have the watt for measuring the power, and we have Newton for measuring the force. The care of electric energy is expressed in kilowatt, and the 1 kilowatt is expressed in 3,600,000 joules. And The heat is expressed in the calories, and the 1 calorie equals to 4.189 joule. Okay, so this is all you have to know about the energy. The second part, which is talking about matter and organic compounds. What do you know, or what comes in your mind when I say the word matter? When I say the word matter, it's everything around us, but it has to have mass and has a volume. And has a volume means to take up a space. So now we are going to talk about the matters and the important compounds that's found inside the living thing. First of all, you have to know what's the main difference between the word compound and the word element. Okay, so actually we have many elements around us. Like we have 120 known elements until now. We discovered them and we put them in a schedule that's called periodic table. These are the elements, the pure form of something. When I say oxygen only, when I say carbon only, when I say helium only, so this is the pure form of things, so this is element. But when I say carbon dioxide, which means carbon combined with oxygen, this is not element anymore, this is a compound. When I say sodium chloride, which means Na combined with Cl, this is compound and not element. When I say chromium Cr, this is basically a pure element. So you have to know what's the main difference between element and compound. Okay. Now we are going to take some important compounds, specifically organic compounds, and organic means they are made up of carbon and hydrogen that's found inside the cell. We have carbohydrate and we have lipid and we have protein. Why we have a carbohydrate inside the cell?